Think back to the promises of artificial intelligence. Machines as intelligent as humans, capable of reasoning, learning, and innovating. We've been told AGI, artificial general intelligence, will revolutionize every industry, from medicine to space exploration. But behind the glossy headlines and billion-dollar investments lies a harsh truth. The journey to AGI is facing a massive roadblock. Why? Because building smarter AI is becoming exponentially harder, and at the center of it all is an unexpected villain: data. Yes, the very thing that made AI what it is today has become its biggest bottleneck. But why is this happening now when we're supposedly on the brink of breakthroughs? And more importantly, how can we overcome it? Today, we're diving into the problem, the stakes, and the possible solutions, including one that might surprise you: plain text meshes. So, let's dig in. But first, to get a better understanding, let's rewind. Over the last decade, companies like OpenAI, Google DeepMind, and Anthropic have poured their resources into building AGI. These are the same companies behind ChatGPT, AlphaGo, and Claude, the technologies that have already amazed us. Their mission? To create AI systems capable of understanding and performing any intellectual task a human can. This isn't just about innovation, it's about economics. AGI promises to unlock trillions of dollars in value, automate labor-intensive industries, and solve problems that seem impossible today. Venture capitalists, private equity firms, and tech giants have invested over $100 billion into AI startups in just the past 5 years. But here's the catch. The promise of AGI isn't just ambitious, it's existential for many of these companies. Their survival depends on delivering AGI. No AGI, no ROI. So what's the holdup? Why isn't AGI here yet? The answer lies in data, or more precisely, the lack of high-quality training data. AI systems are trained on enormous datasets. Think billions of words, images, videos, and sounds. These datasets teach models to recognize patterns, answer questions, and generate creative outputs. But here's the problem. We've already used up most of the easy-to-find, high-quality data. Take text, for example. Models like GPT-4 were trained on vast swathes of the internet, from Wikipedia to books to online forums. But there's only so much text available that's clean, diverse, and relevant. As Bloomberg recently reported, AI companies are now scraping the bottom of the barrel. They're resorting to low-quality, noisy, or repetitive data. And that's bad news for building smarter models. It's not just about quantity, it's about quality. Poor data leads to poor performance. Models trained on bad data might become biased, make more mistakes, or fail to generalize. And this isn't just an inconvenience, it's a crisis. Without enough good data, progress grinds to a halt, and the stakes couldn't be higher. According to insider reports, over 50% of AI companies focused on AGI rely on breakthroughs to secure their financial futures. In some cases, these companies have received funding based solely on their promise to deliver AGI. Let's get specific. OpenAI, for instance, received a $10 billion investment from Microsoft. Google has sunk untold billions into DeepMind, its crown jewel for AI research. Anthropic, another major player, raised $580 million from investors, touting its potential to develop AGI. But it goes without saying, with no meaningful progress, these investments could turn into losses. This isn't just speculation. Tech forums, including Reddit threads like our local llama, are full of chatter about the pressures these companies face. Industry insiders warn that if AGI fails to materialize, we could see layoffs, divestments, and even a shakeout of the AI sector. It's a high-stakes gamble with everything to win or lose. But let's shift gears. What if there's a way forward? A new approach that could breathe life into AI development. Enter meshes as plain text. Now, I know what you're thinking. What's a mesh, and why does it matter? When we talk about meshes, we're referring to the intricate web of points, lines, and surfaces that define the shape and structure of objects in 3D space. These are the backbone of digital environments in industries like gaming, architecture, and virtual reality. Traditionally, meshes are encoded in formats optimized for rendering visuals, formats that are efficient for human use, but challenging for AI to understand without significant pre-processing. Here's where it gets interesting. Meshes contain rich information about geometry, physics, and spatial relationships. But traditionally, this data has been stored in formats that AI models can't easily process. The idea of converting these meshes into plain text, something AI already understands, could unlock a treasure trove of new training material. Imagine training an AI on textual descriptions of 3D worlds, like a chair with 4 legs, a curved backrest, and a smooth wooden surface. This text-based representation would make 3D information accessible to AI models trained primarily on language like GPT. But how exactly would this help? Well, for starters, text descriptions of meshes are inherently more than just geometry. They can also include material properties, spatial relationships, or functional details. For example, a glass cube that refracts light on a table next to a wooden ladder with evenly spaced rungs. This allows AI to learn not just about shapes, but also about their relationships, uses, and behaviors in the real world. Essentially, it merges physical knowledge with linguistic reasoning. By converting meshes to text, we're creating a bridge between the visual spatial world and the textual world. AI models could begin to reason about 3D spaces using the same capabilities they use to understand language. This opens doors for AI to describe 3D environments verbally, generating designs based on prompts, and explain complex 3D structures. On top of that, by converting existing 3D assets, models, simulations, and CAD files into text, we create a vast, untapped new source of training material. Think of the millions of 3D models used in games, architectural projects, and industrial designs. These could all be repurposed to train AI. It's no secret that one of the biggest limitations of current AI models is their lack of physical intuition. They understand language, but they don't truly grasp concepts like gravity, balance, or spatial constraints. However, a mesh-to-text translation could help models learn these concepts implicitly, enabling better predictions and decision-making in real-world scenarios. Needless to say, this approach bridges the gap between the physical and digital worlds, allowing AI to learn in entirely new ways. Of course, transforming meshes into plain text isn't going to happen without challenges. Converting 3D data into detailed, natural language descriptions requires sophisticated algorithms. These systems must capture not just geometry, but also context and nuances. So developing such algorithms has to be a key focus for researchers. Not to mention, language and verbal instructions are inherently ambiguous. Ensuring that descriptions are precise enough for AI to learn effectively will need thorough standardization. Also, who says meshes from gaming would be the same as those in medical imaging or industrial design? Spoiler alert, they would not. Training AI to generalize across these diverse domains will take time and effort. But get this, meshes aren't even the only innovation on the table. Researchers are exploring several other groundbreaking methods to overcome the data bottleneck. First and foremost, we have synthetic data generation. Like a Hollywood set, synthetic data is fake, as the name suggests, but it looks real enough to fool the audience. AI can generate its own training data, creating realistic simulations of everything from conversations to natural environments. Companies like NVIDIA are already using synthetic data to train AI for gaming and robotics. If that isn't mind-blowing enough, there's also federated learning. Why rely on centralized data when you can leverage decentralized data? Federated learning allows AI models to learn from data spread across millions of devices like phones and laptops, without ever transferring that data to a central server. It's a win-win for scalability and privacy. Then, we also have multimodal training. It's no secret that most AI systems specialize in one type of data, text, images, or audio. But the real world isn't siloed like that. Multimodal training teaches AI to process multiple types of data at once, leading to smarter, more versatile models. Last but not least, there are lifelong AI learning models. Unlike humans, most AI models don't learn after they're deployed. But lifelong learning models would evolve over time, adapting to new data and environments. This approach could stretch the utility of existing datasets far beyond their current limits. Now, while these solutions sound promising, they also highlight an important truth. No single company or research lab can solve this alone. Building the future of AI will require collaboration on an unprecedented scale. Imagine a world where OpenAI shares breakthroughs with Google, where startups and academic researchers team up, where governments provide funding and infrastructure for open-source AI development. This kind of global cooperation could accelerate progress while addressing ethical concerns like bias and misuse. But collaboration isn't just a nice-to-have, it's a necessity. Without it, the race for AGI could become a zero-sum game, where companies compete at the expense of innovation and safety. And let's not forget, building AGI isn't just a technical challenge, it's an ethical one. As we develop more powerful AI, we need to ensure it benefits humanity as a whole. That means prioritizing fairness, transparency, and accountability. It also means asking tough questions. Who controls AGI? How do we prevent misuse? And how do we ensure it doesn't exacerbate inequalities? These aren't just theoretical concerns, they're issues we'll face in the very near future. Watch our most recent video on the European Union's recent AI Act, which is set to be the precedent in the regulation arena. It's a start, but there's still a long way to go, to put it nicely. So where does this leave us? Building AGI is harder than anyone imagined, but it's not impossible. The data bottleneck is real, but with innovations like plain text meshes, synthetic datasets, and lifelong learning models, we have a path forward. The key will be persistence, creativity, and collaboration. AGI isn't just a dream for a few companies, it's a challenge for all of humanity. And if we rise to the occasion, the rewards could be extraordinary. What do you think? Are meshes the missing puzzle piece? Or is there another breakthrough waiting just around the corner? Let us know your thoughts in the comments below. Together, we can shape the future of AI.